This is Jack Miller from SED's ASU Rocketry Division. Past two videos I showed you how to build a single stage rocket, which is what we have here, and in the last video we showed you how to do a dual deployment rocket. In this video we're going to do a little more of an advanced tutorial on how to do a multi-stage rocket, which if you're doing a SED's University of Student Rocketry competition, this is actually the competition guidelines is you have to do a multi-stage rocket and stay within the competition parameters. So what I'm going to do is I'm going to take the first rocket we built and just modify it a little bit to make it dual deploy or to make it a multi-stage rocket. We're going to keep the single deployment here just for simplicity's sake, and we're going to actually modify it just a tiny bit for this guy. So you can see, typically when you have one of these rockets, you want to have a coupler inserted down here so that you can attach your two stages together. So what I'm going to do real quick is I'm going to change this fin tabs. I'm going to change the length to about 2 inches, and I'm going to change the position to be up a little bit more. Okay? And what I'm also going to do is I'm going to change this centering ring in the back here. And I'm going to change it, I'm going to push it up a little bit. Okay? And so what that did is it basically gave us a little room down here so we could add a coupler. And when you're designing your two-stage rockets, keep in mind how you're going to ignite the motors. I'm not going to show you that in OpenRocket today, but a typical configuration that we've used is we have the electronics base somewhere up in this second stage with a wire that's routed down through the body here that actually connects into this second stage motor. This is really tricky when you're doing small diameter rockets like this because you don't have a lot of clearance to put that wire here. If you're doing minimum diameter, where say you have a 29 millimeter motor and a 29 millimeter like fiberglass tube, you have no room to run that wire. So you actually probably would have to go outside the body tube and come back and put it in here. And that gets tricky because you're gonna have to mess around with your body tube and stuff like that. But what I'm gonna do now is show you basically how to add a second stage. So we go over here to this design tree, and you can see over here we have our move up, move down, edit, new stage, and delete. Obviously we're gonna click new stage. And when I hit new stage, it pops up right here. It's typically called booster stage, so we're going to keep it like that for now. We're going to close this, and you see booster stage popped up. I'm going to go ahead and add a body tube, and I'm going to make this a 20-inch body tube for now. And that's just a way for us to be able to add a couple components. So body tube, we have the body tube. We are going to want to add a coupler. So we add a coupler. Right now it's at the bottom of the component. I'm going to change it to the top of the component, make this 0. And then I'm going to change, we're going to double check the outer diameter, 38 millimeters, that's good. Inner diameter, 38 millimeters, that's not possible. We're going to change it to, not 26, why do I keep doing that? 36. So it's a little bit, so it'll fit inside of our rocket. Wall thickness, that should be automatically calculated, it should be 1 millimeter. Length, we're going to change the length to, let's see, we're going to change it to, what is it, 42, it's going to be 84 millimeters. So now that's 2 diameters basically of the rocket. And we're going to change the position relative to this guy to 42 millimeters. I might have to do negative. Yeah, I got to do a negative value. So negative value, you can see it goes up into the second stage real quick. And something that's always useful to double check is now that we have a second stage, we have stages here. So if I click second stage, it shows every stage above it, which can be a little frustrating if you just want to work with the, the first stage basically. If we hit the first stage, this top stage, you can see it pops up here. One thing to double check when you're doing this is make sure that when your coupler is here, you want to make sure that when you click on first stage, the coupler is not attached. Because in how you're going to operate in real life when you launch this rocket is you don't want that coupler attached at all. And that's something that you'll have to double check. You can even see it in the design tree. You just want to make sure this coupler isn't attached to this stage. Okay, so we have all this. What we're going to do now is I'm actually going to take this parachute. I'm going to copy this, and I'm going to paste it into this rocket right here. I'm going to copy the shock cord as well, just for simplicity, and I'm going to glue it, or paste it into this guy. So now we have a shock cord and our parachute, basically. And also, I'm going to increase the length of this, just so it'll be a little bit easier on me. You can see when we did this, the stability went down because your fins, right now OpenRocket sees it, it's a surface area, stability is calculated with surface area, and you have these fins way up here and you have this huge surface area, and it's going to make our stability go down. So if we were to launch the rocket right now, it would spin around and crash and burn. We don't want that to happen, and you're going to have to typically add fins, which is, you have to do that basically 90% of the time unless you have a bunch of nose cone weight which I've experimented around with, but it's much easier just to add fins. So we're gonna make sure this is a fiberglass, and what we're gonna do is we're also gonna call this the motor mount. We're gonna do a 38 millimeter motor down here. Motor hangover or overhang, not hangover. We're gonna say a 1/4 inch. I think I have to say -1/4 inch, right? We'll see what happens. And let's see, we're gonna add some fins. Or actually, first let's add the motor. So you can see when we changed all that stuff, it changed our configurations automatically. So we have an inner tube now and a body tube. The inner tube is this top tube down here, or this tube right here. The body tube is going to be this guy down here. And remember, you can rename these. You don't have to have it named body tube. If I wanted to change this body tube name, I could change it to first stage awesomeness, or just awesome. Like that. We're just gonna, whatever, call it that. That'll be fun. Well, I guess I misspoke. I guess I didn't change it here. I was kind of excited for that to happen. But body tube is changed, and we're gonna go ahead and add a I-285 red line. And this is a configuration that we used in our very first rocket that actually won 2nd place in the nation for the USRC competition. And you can see I got the overhang wrong, so I'm gonna go back and change that. We did not do a 42 millimeter body tube. We actually did a 2.6 inch body tube, which granted wouldn't give us the maximum altitude, but because it was our first time doing it, we really wanted to make sure that we got it right. And so that's why we chose a larger body tube, so we have enough room to work with it. All right, so we changed that, and you can see our stability factor is really bad now. It's -6, which is horrible. So what I'm gonna do is I'm going to add some fins. And let me help you guys out by zooming in on this. We're gonna zoom in about 50%. And I'm gonna take these fins and I'm going to increase the root cord to about right there. Make sure we have our fins lined up. So we had 4 fins on the upper stage, we want to have 4 fins on the lower stage. Or the first stage, second stage, whatever you want to call it. Tip cord, let's say that's maybe 1.5 inches, why not? Height, we're gonna call it 2 inches. And sweep length. Change it to something like that, and we're also going to change the position. Okay, we have to do a negative number. Okay. So this is now a 2-stage rocket. If I go to just fit, we can see how it looks. So here's our 2-stage rocket. We have a stage up here. We have a stage down here. We have 2 sets of fins. We have recovery for each stage. First stage here, sometimes you can do a streamer if you really want to, because it's not going to be that heavy, and it might work out for you. We had a parachute in one of ours, and anyway, so you can see our stability factor is really high. It's at about 4.38. Now that's a stability factor for this entire rocket, and that's good to know because you want this stability factor to be high. We can change the height if we want. We can change it to 1 inch. See what happens. It's about -1 right now. We don't want that. We want to change it to about 1.5 or something like that. Have the same height as the previous stage. And stability factor of 2, which is pretty good. And one thing you can do now is you also want to double check when you're designing that your stages preceding your first initial entire launch vehicle, you want to make sure all the stages after that are stable as well, or at least going to be stable in flight. So you might be going at 400 feet per second, and that might cause your rocket to be stable in flight, but you want to double check in here and also double check with simulations. So you can see we're pretty stable right here. I'm gonna actually change this to about 1.25. So everything looks good for now. Now what we have to double check is our parachute in here. We want to make sure that's deploying at a correct stage or a correct point. So it's at apogee. That's really good. That's what we want to have happen. And this one, this parachute, I think I did not change it from the previous one. No, it's at apogee. Okay. And so everything's deploying at apogee of their individual stage. So this stage, OpenRocket, as far as I know, what I've been able to tell is it simulates these as being a drag release. You don't have to tell this stage to separate. As soon as this motor burns out, your rocket stage will separate because it'll have more drag, it'll pull it out, and basically, because this should be just a friction fit for now, and it should be loose enough where you could pick up your rocket and this stage should fall out. So that way when the drag, after you're done having the force that's pushing it up, the drag is going to pull it down basically. And it'll come down and it'll continue on its ballistic path before this parachute eject basically. And we typically have ours, depending on what we're doing, we just have the ejection charge from this stage shoot out this rocket, or shoot out the parachute. And you might have to mess around with the ignition, the delay on that to make sure it's going to go out on apogee. Okay, so what we're also going to do now is the trickier part of this. If we just go to flight simulations, we don't care about anything else right now. Let's go to simulate and plot, and let's just see what happens. I'm going to choose some interesting stuff right here. Launch rocket clearance, ejection charge, stage separation. We want that. Apogee, recovery dash deployment, ground hit, simulation end. Okay, that all sounds good. So we hit plot, and you can see that our altitude has increased significantly from just our single stage rocket, which should happen. Rocket goes up. You can see that we have motor ignition and stage separation right here. And then you have motor burnout of the second stage in this line, and then you have apogee device deployment for this guy for this first stage, and then apogee deployment of the parachute and the second stage. We're going to double check this guy right here. This is an interesting one. It's motor ignition, stage separation. That's pretty interesting. So maybe I'm incorrect. It's possible that the stages stay together until motor ignition, but we're going to double check that. So you can see you have your simulation here. What we're also going to look at is motors. So this one, if we look at the ignition, we're going to do select ignition, and let's see, it's automatic launch or ejection charge, but we don't want that. We want to have set at the first burnout of previous stage. If we have it set at that, let's go back to our flight simulation and see what happens. So you can see our altitude's decreased a lot because we immediately after this first stage burned out, we started our second stage motor. That's not typically what you want to do. It's up to you, but OpenRocket simulates as soon as that one burns out, it's ready to go. Typically your motor will take a little while to light, maybe half a second or something like that. But you also want to try to change the motor ignition to allow yourself to coast a little bit, which will allow you to gain a little bit more altitude. But you have to be careful because if you let it coast for too long, your rocket might approach apogee and actually start turning sideways, which will lose altitude. If not, if your rocket's exactly at apogee and you try to ignite it then, it might shoot straight into the ground, which would be really bad. But we're going to add a couple seconds here. We're going to add like 3 seconds, see what happens. And double check our apogee right now. It's 7,799 feet. We're going to hit OK, and you can see our apogee increased, which is good. If we go to our flight simulation, hit new simulation, and we hit plot, check out what happened. You can see our apogee increased because when we had motor burnout, and then right here is where stage separation occurs and motor ignition, and it burns all the way up here. And so that's something you're going to have to mess around with. You're going to have to change the delay on your second stage motor ignition to figure out what you're comfortable with, what you think will, how long it'll take basically for that second stage motor to ignite, and how long you think is appropriate to make sure your rocket's pointed straight up still and not going to be pointed sideways or towards the ground, which would be really bad because you're going to lose a lot of altitude that way. Let's see. One thing we would always suggest is to have some sort of tilt control on your whatever your electronics are for the second stage. That way, if your rocket's tilted too far, it's not going to ignite, which is really good. So say if your rocket's tilted at like 30 degrees from 30 degrees down or something like that, it won't ignite, which is really good because that's pretty safe. It'll also prevent you from hurting anyone basically. But you always want to make sure your rocket's still pointed straight up. So that's just kind of our little tutorial on two-stage rockets here. Let's see, we're hitting about Mach 1, which is good. You can always double check what speed your rocket's going at when you have device deployment, when your stages are going to separate. And one thing you can do here, you can see this is probably not an ideal rocket, or it might not be how you're going to design it, because this is a really big stage. You might not need this much room for a parachute. But that's up to you. You're able to mess around with it. You're able to add avionics to it. You're able to add flight computers, check out the individual stages, as well as add trackers to it. That's something that's going to be really important. If your rocket's going to go really high, we usually try to put a GPS tracker in it so you don't lose your potentially $1,000 rocket, which would be really bad. But this is how we do two-stage rockets. The next tutorial is going to be on some more advanced functions of OpenRocket. stuff that we typically use as like advertisement stuff like that. We make pictures out of it, as well as some of the different tools you can use on OpenRocket to improve your designs. So please check out the next video in this series. Thank you.